Hello everyone, and welcome to Module 5 of INST728E, where we'll be talking about frequency and time series analysis of social media data during crises. Now, what does this mean when we talk about frequency and time series? Really what we're talking about is taking a tweet or a message from Reddit or from some other social media platform, extracting the time in which that tweet was posted, and then plotting that information over time. This gives us insight into the sequence of events during a particular crisis. So for instance, this is a graph of tweets and their frequencies during the Ferguson, Missouri protests several years ago. And the blue line represents the frequency of tweets that include the term Ferguson, and the red line at the bottom includes the frequency of tweets that mention tear gas. The green line is frequency of tweets that mention Obama, and the light blue line is the frequency of tweets that mention Iraq. And we see some spikes in all of these different lines, and that gives us some information about what has happened. So we see here at about 7 p.m. Eastern Time versus 2300 UTC time on the graph, we start to see an increase in tweets that mention the word Ferguson. This was the onset of protests and coverage in social media. Now, several hours later, we see these tweets that mention Ferguson reach their maximum. This tells us that this is when people were most engaged discussing this event. Likewise, we see a spike in the red line mentioning tear gas, giving us some insight into this is when reports of tear gas usage became widespread during the coverage of the Ferguson protest. Here we have another spike around 3 a.m. I think this corresponds to when the Washington Post journalist was arrested at a McDonald's. And then here we see a spike at 1 p.m. on the next day when President Obama gave his speech regarding the events in Ferguson, Missouri. And we see a spike both in the blue line, the general frequency of tweets that mention Ferguson, and in the green line about tweets that mention Obama. So we can look at these tweets ordered by the time in which they were posted to start to build this timeline of events during these crises. The first step in doing this, however, is to figure out when a particular social media message was posted. Now with tweets that we'll be looking at during this module, tweets have a created at field embedded in the JSON metadata. It looks like this example I've shown you. This one was from Sunday, July 14th, 1836 UTC time in 2013. So this is just a random date. But this is the kind of format that you'd expect. And then we want to be able to convert this created at string into a real date and time object in Python that we can use to do ordering. So how do we do this? So we want to take this Sunday, July 14th text and convert it to a date-time object. Well, Python has some nice features or capabilities for extracting or converting strings of time into these date-time objects. But the first thing we need to know is the format. So all tweets have the same format, where it's the day of the week, the month of the year, the numeric day of the month, followed by the hour, minute, and second in UTC time. That plus 0000 refers to the UTC offset, so it's 0 since we're using UTC time. And then we have the year. So once we have this format string, we can use the strip time or strp time function from the datetime library in Python to convert this time string to a datetime object. And then once we do that, we can study the number of messages per week, per minute, per hour, per day, whatever our particular time slice is. In our module for this, we'll be looking at per minute, but you can look at per hour or per day as well, depending on the kind of event you have. And once we do that, we'll also look into keywords during crises to give us some insight into particular events or particular references during the event. So in this example here, as I mentioned, we have included lines for Obama tear gas in Iraq, and that gave us some more insight into what was happening. Like the green spike at the end lets us know that that's when President Obama spoke. And then from there, we can look at things that we looked at in the last module, like common hashtags, common URLs, etc. But we'll look at this both in terms of temporal relevance. So this is tweets that were posted after the event or within some small time frame between the beginning of the event and maybe an hour later. And then we'll look at textually relevant tweets as well and what the common hashtags and URLs and users were. So tweets that include some keyword that we've decided on. And then we will talk about saving these relevant tweets or tweets that we've identified as being relevant, especially the textually relevant tweets, to a file. And that we'll use for the remainder of the course, which will save us a lot of time in doing this filtering. But you'll need to pay attention about doing a good job in figuring out what these keywords you want to search for are. And we can talk about how we will do that. Now for this homework, or the homework for this module, basically what I want you to do is take the target event that you selected. You should have now selected this disaster that you find of interest. Choose a few keywords or phrases to describe this event. Identify a particular time in when this event occurred that you want to focus on. And then estimate the time of the disaster using frequency analysis in Twitter. Does this estimate line up with when you actually know or think that the event occurred? Now, for a terrorist attack, this could be the time that the first bomb went off. In our example, in the example notebook that I'll show you in a few minutes, we will go through and look at the Brussels bombing. So this gives us a nice, very discrete time frame to look at it, when a particular bomb exploded. For other kinds of events, like hurricanes, this is a little bit more unclear because it's unclear exactly when the beginning of a hurricane occurs, right? So do you look at when the hurricane was first detected? Do you look at when the hurricane first made landfall? And this is going to be a little bit more nebulous and may take some more insight from you to figure out how best to figure out the time. And then when people most start discussing the event also gives you some insight into maybe it was landfall, or maybe it was a couple hours after landfall when the hurricane became most severe. Once you've done that, use this analysis and an analysis I've provided you in the Module 5 notebook to identify 5 new keywords, hashtags, or users that you should have included in your event description. And then you can use this to expand your event description, which will allow you to make for or create a better relevant data set at the end of this module. All right, so now we'll move on to the example notebook. So here we have our list of notebook modules. I'll go ahead and click on module number 5. Now we'll have several things that we can look at here in terms of the libraries that we'll use. So first off, we want to look at parsing out time. So we're going to use the date time library. We're going to look at JSON and do all these things that we've discussed from the previous module. So we need the JSON and gzip libraries. And then we're also going to be doing some tokenization like we did in the last module, so we'll need the NLTK tokenize and stop words corpora as well. So what we'll do in this module is we'll first look at parsing out time, so figuring out what time a tweet was posted. Then we'll use that information to graph these frequencies. And then we will look at the frequencies of individual keywords to get some insight into the sequence of events during that disaster. Then we'll zoom in a little bit more on a particular event, both temporally, so the 60-minute time frame around an event, and then textually as well. So tweets that include some set of keywords that we thought were interesting, what is common in those keywords as well. So first off, we'll go ahead and do all these imports. Then we will define our event. I provided a skeleton definition here for the Brussels bombing. Now, I encourage you to go through and modify this crisis info map into something that reflects the event in which you are interested. So be sure and change this name here. I have it as Brussels to some other identifier. And then you can update the name. See here I have Brussels transit attacks. You can call it Hurricane Harvey, Boston Marathon bombing. Here's the timestamp I came up with for when the Brussels transit attack occurs. This corresponds to 22 March 2016 at 6:58 in the morning UTC time. So how might you come up with this time frame or this time stamp? This is called the epoch time, which is a very common timestamp format in data storage. So to get this timestamp, if you need to, you can go to epochconverter.com, which will let you put in a month, day, year, hour, minute, and second in some human date, and then convert that into an epoch timestamp here. And that's the number of seconds since January 1, 1970. Okay. Now, once you have that time frame, you can drop that in here. The directory is just some directory where data is stored. You need to change this to wherever you've put your data. You can put dot for the current directory. The keywords are the keywords that you've identified. So for us, in this example, where we're looking at the Brussels Marathon or the Brussels airport bombing, I have Brussels, bomb, Belgium, and explosion. So that's important to update these. And then I've put in a bounding box for where the event occurs. Now, you don't have to worry about that during this module. We'll look at that in the next couple of modules. So if you don't want to put that in now, or you don't have this information now, that's fine. We'll talk about that later. So we'll go ahead and define this. It's important to note that you can leave the Brussels one in here in this crisis info map, because since it's a map or a Python dictionary, then we can have multiple keys and values. So you can put some other value here. So say you wanted to do the Boston Marathon bombing. So you could define another set of data here. And this might be useful if you want to follow along or replicate the Brussels analysis as well. All right, once we have defined our disaster or our crisis, then we can go through and start reading tweets from it. So since we have this crisis info dictionary that we've put together, I'll go ahead and say, well, the selected crisis we'll use is Brussels. And then from there, we can start pulling out data. So here we have tweet directory. This will go to the crisis info dictionary that we've created with the selected crisis and the directory where that data is stored. And then we will figure out where all this data is. So for me, I put it in a temporary directory in my home folder. You can put this anywhere else. So this OS path sep thing is basically whether it's a / or a /. This is different between OS X and Windows. And then from here, you can put either all this information directly where your file's stored, or you can just put a dot for the local directory. So if everything was stored in the same directory as this notebook, then this line may just look like this. So this will give us a name, all the different file names that I provided you of sampled tweets for your particular event. And then we want to read these files, so this will be nice to print this out for us. And the next thing we'll do is create another dictionary for the different times that we've seen. So this frequency map will have a key for a particular time, in our case, a particular minute, where a tweet was posted, and a list of tweets that were posted during that minute. This time format is the Twitter time format that I showed you in the slides a few minutes ago, and we'll use this to parse out the date time from a particular tweet. And then we will read all the different files from this directory where our data files are. And we'll do what we saw before, where we will open them using our gzip library since they're compressed. We'll decode to UTF-8, so this will give us emoji and other content that might be in these tweets. That's not regular alphanumeric characters. And then we'll go ahead and try and load them in using JSON, so you've seen that already. We do have an exception here just in case there is a decode error, so for some kind of tweet artifact like a delete message or something, this will catch those and just skip them. Same thing here. If a message is considered a delete message or a status withheld message, which you may see if you creating your own data set in the data collection module that we just did. All right, so now assuming that we make it to this part, we have a tweet object in our tweet object variable that corresponds to a tweet. So it has the tweet text and user and all these things that we saw in the previous module on parsing Twitter data with JSON. And now we can extract the current time. So the tweet object created at will be that string I showed you before about when the tweet was created. The time format is this time format up here at the top, which will be the same for all tweets. And then we'll use the datetime strip time function to convert this string to a datetime object. And then we'll catch any sort of error if an error occurs and then skip that tweet for whatever reason. Now, the last thing that we'll do that I'll say is of note is this, flattening the tweet's time. So here what we'd say is whatever time a tweet was posted, we're going to go ahead and replace the number of seconds in that time with a 0. So this says if a tweet was posted at 6:10 and 27 seconds, then we'll go ahead and make it say the tweet was posted at 6:10 and 0 seconds. Now we do this because what we want to do is say all tweets that were posted in a given minute should have the same key in our Python dictionary. So this means that all tweets that were posted between 6:10 and 0 seconds and 6:10 and 59 seconds should all map to the key 6:10 and 0 seconds. Now you can do this for any part of the tweet time as well. So if you wanted to look at not the minute, but the hour that a tweet was posted, and you wanted to bin all of your tweets together at the hourly level rather than at the minute level like we're doing here, then you'd want to say second equals 0 and minute equals 0 as well. So what this would say is all tweets that were posted in a given hour, go ahead and flatten that down to assume that all those tweets were posted at the first minute and the first second of that hour. So we'll go ahead and delete that minute. Now that we have this current time flattened out to a particular minute, then we can say we'll go to our frequency map. This is our dictionary of times that we've seen, the tweets that have been posted in that time. And we'll say check if that current time exists in our dictionary. If it does, return this list of tweets. If it doesn't, then we return an empty list, saying we haven't seen any tweets at this particular time before. So then we'll take this list that we just got back, add the current tweet to it, and then update the frequency map with this extended list. Now this line is important because if this current time did not exist in our frequency map, then we would get this new list that we'd be adding to. So we need to go ahead and update our frequency map with this potentially new list. All right, so we'll run that. Now this will take a few minutes depending on how much data you have, how fast your machine is, and some other factors. So we'll go ahead and let this run for a few minutes. So now we've let that run, and we can see that we've read in 7 data files running from 5 a.m. UTC on March 22nd to 11 a.m. UTC. So this is 7 hours or 8 hours worth of data. And you may notice that these files were read in out of order. That's fine. We won't care about that for now. We'll actually go ahead and sort that data set here in this next cell. So here what we'll do, we say we'll fill in any gaps. What this means is we'll take all the times where tweets were posted, or all the minutes in which a tweet was posted, and we'll go ahead and sort them. So this is one of the reasons to convert from a string to a Python date time, because then we can do sorting very quickly. And these times will be a list of sorted minutes in which tweets were posted. We want to make sure that if there was a minute where there was no tweet posted, that we capture that in our list as well. So we want to fill in any gaps. That's what we mean by that. So we'll start off by saying, well, what is the first time in our list of times? This is the 0. Then we'll look at the last time in our list of times. And then say, well, starting at the first time, we want to fill in any gaps. So we will look at this time interval step and say this is a time delta of 60 seconds or 1 minute. We'll do this while loop where our current time is less than the last time in our sorted list of times. As long as that's the case, then we will update our frequency map with either whatever the list of tweets are in that time or a empty list if there were no tweets during that time. And then we'll do this time interval step thing that says take whatever our current time is, we'll add 60 seconds, this time interval step to that time, and we'll update that as our current time. So this will iterate through every minute in our data set. And then after we run this, we can say, well, whatever our start time and stop time was, we can print those out and look at the number of minutes between our start and stop time, and then how many tweets that we saw, or look at how many tweets we saw during this time frame. So we go ahead and run this, and we see, well, we started at 4:59 with 0 seconds, and we ended at 11:59 with 0 seconds. This is consistent with these status files that we saw up here. So there are 421 minutes between these two time frames, and we captured approximately 230,000 tweets to look at. So now we have a dictionary, this frequency map, that contains 421 minutes as keys and a list of tweets that were posted during each one of those minutes. Now from there, we can actually plot this information. So the first thing we'll do is we will take our selected crisis, so Brussels in this case, and whatever time that crisis occurred, and convert this to a date time as well, so we have a consistent data set or a consistent time frame. And then we'll place this with 0 to make sure that we have the correct minute in which this event occurred. Go ahead and print this out for debugging purposes. And then what we want to do is create a figure where we'll plot out the tweet frequency. So we take our sorted time, so this is the sorted minutes in our frequency dictionary. We can print out this time frame, and then we can get a list of the number of tweets per minute. So this is a list comprehension that says for every time in our sorted times, go to the frequency map dictionary and get me the list of tweets that were posted during that time, and then we will figure out the length of that list of tweets. So it could be 0 if no tweets were posted during that time, or however many tweets were posted during that time. So this gives us a list of the per minute frequencies of tweets that were posted. Then we can plot that, so we plot that here with this ax.plot. That's the post frequency list that we just talked about. This length, the frequency map and range just gives us X data from 0 to the number of minutes that exist in our data set. And here we do one additional thing where we will print or plot when that crisis occurred. So we can go to our sorted times. This is our list of minutes, and figure out the index of the time where the crisis occurred. So this just gives us what is the X value of this crisis time. It'll let us look and see when tweets occurred versus when our disaster occurred. We'll see that in a second. And then we can do a quick scatter plot that just says it has one data point, the X coordinate for our crisis, and for simplicity, we just take the average post frequency or tweet frequency as our Y coordinate, and then we put a little red X there to let us know that that's when the crisis occurred. And the rest of this is just plotting, so we make our grid and a legend and set our labels for our axes. The one thing that I hadn't talked about yet, though, is this piece right here where we look at X ticks. So if we don't include this X ticks point, or this X ticks code, then it'll just show us in the X axis a 0 to 420 for the number of minutes. But what we want to have is times, not these indices. So what we do is we look at the sorted times, we take a range from 0 to the number of minutes, and then we slice it up into 30-minute increments. And then in that 30-minute increment, for each one of the ticks that happen at this 30-minute increment, we pull out the sorted time in that moment. And then we can use that as a label. And we'll see what that looks like in just a second. So we'll go ahead and run that. We see the time of our crisis. It was at 6:58 UTC on March 22nd, 2016. So our time frame is from about 5 a.m. to about 12 p.m. on the 22nd. And now we get this nice graph here, where the blue line is the number of posts per minute. This red X is the time frame when our crisis occurred, or when the explosions first occurred. And here at the bottom, we have a label for the date and time for that moment in the x-axis. So here we can see at 6:59, a little bit right before that grid line for 6:59 is when our crisis occurred. Now, this is where the X-ticks piece came in. If you find that your data is too sparse or too dense in this X-axis, then you can change this 30 here to some other value. So you could do 15 for 15 minutes or 60 for an hour, and that would alter this information here. Now we see that there is a down and then upward trend in this data for the number of tweets posted per minute, with some average around 550 tweets per minute. But note that when the crisis occurred, we were towards the bottom of this frequency curve, and then it starts to pick back up over the course of the next several hours. Now, this might be because people started using Twitter more to comment about the event, or more likely, this was a tweet that was posted early in the morning, or rather this event occurred early in the morning, and people start using Twitter more as the day goes on, as people wake up and then start to use social media. Okay, so now we can look at zooming in on a particular event. So if we're talking about looking at tweets that are about a terrorist attack, then tweets before the terrorist attack are probably not hugely relevant, unless there's some very strange but potentially interesting behavior where people are talking about the terrorist attack beforehand. But in general, for terrorist attacks, tweets that occur before the event are not hugely useful because the event hasn't occurred yet. For events like natural disasters, like wildfires or hurricanes, then the event time frame can be a little bit different, and I'll leave that up to you about how to best account for that. But for our purposes here, we'll zoom in on an event, or we'll zoom in on the time frame immediately after the critical point of our event. So what we want to do is look at, say, the first 60 minutes following an event, but we want to discard any tweet that happened before our event. So we already have our crisis time, which is what we pulled out in the previous cell to let us draw that red X in our plot. What we want to do is look at all tweets that occurred after that crisis time and within maybe 60 minutes. So we have here are all the time frames. This list after event times will have all the time frames that we're going to look at. This relevant time span, I just chose 60 here. That says look at the first hour after the event. And then what we want to do is for all the times in our sorted times list, which is something we created in the previous couple of cells, we'll check to see if that current time is after our crisis. If it is, we'll add it to our list of interesting times, and then we'll increase our current time span count. And then if at any point in time our current time span count is greater than the relevant time span, then we'll go ahead and break. What this means is after 60 minutes, then we will stop looking. You could as well check to see if the length of after event times was greater than relevant time span, but I thought this was a little bit more readable. So we'll go ahead and run that. And now we can look at the temporally relevant tweet frequency. So this says, starting from our crisis and going in that 60-minute period, let's look at the number of tweets per minute there. So note that we changed our X-text to some slightly smaller value since we're zooming in on a smaller time frame. Everything else is pretty much the same. This post frequency list, where before we had used for X in sorted times, here we'll use for X in the after event times. This is this 60-minute period that we just created. And we'll go ahead and run this after call plot on this post frequency list and the after event times. And we get this frequency plot now. So we see right after the event there was a spike in the number of tweets in our data set, and then it starts to gradually decrease over the next 60 minutes, but we have a lot of these spikes here. So now that we've looked at this data set, or that we've narrowed our scope to this 60-minute period, starting from when the event occurred to an hour after it, we can do some additional analysis, like what were people talking about, the same kinds of analyses that we did before in terms of frequent hashtags, frequent tokens, etc. So to do that, we want to create a list of tweets that were temporally relevant, or a list of tweets that occurred during this 60-minute period. So we'll do a list comprehension here and say for every relevant time in this after event times list, go to the frequency map, our dictionary of tweets and of tweet times to tweets, and get the list of tweets that occurred in that time. And then for each one of those tweets, just return that. So this will give us all the tweets that occurred in this 60-minute period. So in our case, that's about 28,000 tweets. So we've already, in terms of data reduction, we've gone from about 230,000 tweets to 28,000 tweets. So about an order of magnitude fewer tweets to zoom in on these particular pieces of data. Now what we want to do is look for the most common tokens during this 60-minute period. So we've already seen how to do this in the past. Basically, we'll go for every tweet in this list. We will tokenize this tweet's text into a set of tokens, and then we will make this lowercase. So this tokens list will give us a list of all the tokens in this tweet list. We'll do some simple filtering here and say if that particular token is not in our stop word list and it is larger than or longer than 3 characters, then we'll keep it in our list of tokens. So this gets rid of punctuation and small words that we may not get much information from. Then we can go ahead and print out this total token and unique token count and use the NLTK's frequency distribution to find the top 10 or top 20 most common tokens after this time period. Now, keep in mind, we only looked at time frames. We haven't had any sort of information about what is relevant in terms of language. But what we see here is in that 60-minute time frame, we already start to see references to airport, explosions, but a lot of the rest of the stuff, or a lot of the rest of these tokens may not be relevant. So this is the Arabic for Allah, so is this. This HTTPS is common for URLs, like, love, good time, life, para video. Most of these are not relevant to our event. But we start to see that people are beginning to talk about this event. If we do the same thing for hashtags, then we can see the same kind of phenomenon where our first couple of hashtags are not really relevant. So EB Holy Tuesday, Our Heart Awards, Pimp My Summer Ball, Android games, etc. But we do start to see things relevant to our event in these frequent hashtags. So we have Brussels, Zaventem, potentially flight log, Brussels Airport, a lot of information that seems to be relevant to this event. Now, if you had just looked at frequent hashtags and frequent tokens without doing any kind of filtering, then you would probably not see this kind of information. So we looked at the frequent tokens, we looked at the frequent hashtags, now we can look at frequent users, and we see most of these are probably not relevant, so Toshido Rugby or Shinobi Ninja. And then we can look at frequent URLs, and we see all of these URLs are essentially spam. There's nothing here that's particularly relevant to our event, because Twitter has a lot of spam in it. And the next thing we can look at are retweets, or very popular retweets after an event. Now, if we look just at popular retweets without any sort of filtering, then you'd end up with tweets from celebrities. So one of the most popular retweets of all time is from Ellen DeGeneres, and it still gets retweeted even now with something like 20 million retweets. So to account for this, we want to look for retweets in our list of temporarily relevant tweets. So we'll do this filtering here and find all the retweets in our temporary relevant list. So this will give us some amount of information. But we also want to filter out retweets where the original tweet was posted before our event. Because if the original tweet was posted before our event, odds are it's unrelated. So what we'll do here is say, strip out the time for when a particular retweet was created. So tweet.retweeted status gives us the metadata around the original tweet. And we can look at the created at field to figure out when that original tweet was posted. And then we can say, does this tweet, or was this original tweet before our crisis? If it was not, then we will keep it. If it was before our crisis time, then we'll throw it away. This gives us a restricted list of retweets. So this is the recent retweet count here, where it should be lower than the retweet count we saw right there. Now we can get the ID and start to look at retweet counts to figure out how common these retweets were. We can get the unique ID for tweets, so we can figure out how many times each particular tweet was retweeted and find the maximum retweet count for each tweet ID. Then we can go ahead and sort these up to get the top 5 most retweeted tweets and print them out. And what we'll see, so we dropped the number of retweets quite a bit. We see here that the most retweeted tweet after the event, or in the 60-minute time frame, was a retweet about Justin Bieber, or was Justin Bieber's tweet about Kanye West, and another tweet about Kobe. But here, our third most frequent retweet, or our third most retweeted tweet, is about the Brussels airport explosion with an image related, and then another tweet here about people running for cover after the first explosion in the Brussels airport. So we're starting to see things that are relevant to our event being mixed in with the typical spam that you see or unrelated content that you see on social media. Okay, so that looks at filtering social media based solely on time. Now what we want to do is base it on keywords as well, because we can get a lot of information and do a lot of filtering that lets us remove things like these tweets about Justin Bieber, tweets about Kobe that don't seem to include any information about our particular event. So early on, I asked you to have a list of tweets, or excuse me, a list of keywords that describe your particular event. Here I use Brussels bomb, Belgium explosion. And what we'll do at this point is look for tweets that include these keywords. So for each, this target count map says for each one of our target keywords, we're going to create a list of times for when tweets were posted that mention these keywords. This long block here actually just goes through our sorted times and then breaks this up and checks for tweets that include each one of our target keywords, so Brussels bomb, Belgium explosion. And then we will plot each one of these frequency lists using that code here. The only additional thing that I will note is rather than using a plot function, we'll use a semilogx function because the number of tweets that are in the overall Twitter volume are going to be generally higher than, or much higher than the number of tweets that mention these keywords. So we don't want to just collapse all of our frequency down to essentially 0 with this one high line. This semilogY function says plot the y-axis and log scale, and we'll see here this looks in this scale it says plot in powers of 10. So tweets that are just a few tens to hundreds show up here versus tweets that are in the thousands show up here, as opposed to having this one line way up high and all these other lines here essentially 0. Okay, now what we see is this blue line, the number of tweets in our entire data set, is essentially constant or seems to be relatively constant with no major response to our crisis. But if we look for Brussels bomb, Belgium explosion, we see marked upticks in when the event occurs as people start discussing the event. So we see this orange line, a huge uptick in discussion about Brussels that jumps up and then stays high. For explosion, we see a big spike in references to explosion, then it kind of drops off. And then for bomb and Belgium, it's less popular than Brussels, but we still see some usage here that we didn't see before. So if we look at this time frame, so we know the event occurred at 6:58 in the morning, and within about 15 minutes, people had already begun talking about this event. So this gives us some insight into when the event occurred. So now that we have these tokens, we can start to say, well, we know that it seems that Brussels and explosion seem quite relevant to this event. People were using these words to discuss the terrorist attack. So we can zoom in on tweets that mention these keywords. So what we'll do is we'll do some filtering here that gives us all the relevant tweets for a particular token. So what we'll do is look at all times after our crisis time, and then look at all tweets that occurred after this point in time, and filter them based on whether they include one of these relevant keywords. And we'll create a dictionary that will point at, or that will map these relevant keywords to all the tweets that contain them. So we'll go ahead and run that, and we see these counts for the number of tweets that include Brussels, bomb, Belgium, and explosion. So we see far and away Brussels was the most common keyword during this time frame from our list of relevant keywords, with explosions having about, or the explosion having about half as many tweets. Now from here we can say this relevant keyword tweets dictionary tells us here are all the tweets relevant or mentioning a particular keyword. And we can go through and get the number of hashtags, or we can look at the frequent hashtags, users, and URLs for each one of these keywords. This is what this does. It essentially says for each target keyword and all the tweets that are relevant to that keyword, we'll do the things that we've now seen a bunch of times in looking at frequent hashtags, looking at frequent authors, and then looking at frequent URLs. And we see this printed out here. So for the keyword Brussels, frequent hashtags include Brussels, Eventum, Brussels attack, Brussels airport, pray for Brussels, breaking, Belgium, Malbeek, pray for Belgium, a news channel, Brussels with some alternate spellings, users that were discussing this event, like France 24 is a news station, Israel Flash, FD News, common URLs that are about this event. So we see lots of URLs from news stations, so BBC, CNN, ABC News. Frequent hashtags that appear around bomb include Brussels, Brussels airport, Zaventem. Zaventem is the name of the airport in Brussels. Other spellings for Brussels. More content from BBC. Here's an image. So we can click on some of these links to see what people were discussing. So this is an article from BBC News about the Brussels attack in Zaventem and Malbeek. So you can see coverage of the event here, and then we see other frequent hashtags and tokens and authors associated with the other keywords as well. So all this is a bunch of information or a bunch of things or a bunch of content that occurs in conjunction with these keywords that we thought were important. So this gives us all the different information, or all the different tweets per keyword, or at the per keyword level. What we want to do then is merge all this together so we can say, well, people are probably referring to Brussels and bomb and explosion and all simultaneously. So we want to merge all that together. So in our relevant keyword tweets, this is a dictionary mapping our keywords to tweets. We'll get all of the tweets out of that, and then for each tweet in this local tweet list, we'll create a pair of tweet ID to tweet. So this gives us a nice map of all of our relevant tweets. Regardless of which keyword they use, it'll all put us together in one map of tweets. So we have about 5,000 relevant tweets. So we go ahead and pull out those relevant tweets using this maps values function. And then for each one of these tweets, for each one of the tweets in these textually relevant tweets, we'll tokenize it up using the Twitter tokenizer, make all these tokens lowercase, and then do some filtering. And then we can look at frequent tokens, frequent hashtags, frequent users, and frequent URLs merged across all of these keywords that we thought were relevant. So now we see hashtag Brussels as the most common token, followed by Brussels airport explosions, metro explosions. So now we start to see references to the bombing at the metro station, which happened several minutes later, maybe 15 minutes later after the attack at the airport. And we start to see references to the metro, which happened sometime after the explosion at the airport. And we see references to everything, or all these, and we see references to the event pretty significantly here. And hashtags all seem to be about the event as well, which is good. This means that the keywords that we chose are relatively high signal in this way. So we can look at some of these users who might be relevant. So we can look at who Kyle Ratio is. So you can go to twitter.com and put in one of these usernames. So you can look at people who were very active in this conversation as well. And then we can look at common URLs like breaking news, BBC, CNN, etc. In the next module, we'll look at actually extracting media from this, so you can identify images from your event as well. So now that we've done this, the last thing we want to do is save all of these tweets that included some of our tokens in a file that we can use later. So that will save us from having to do all this filtering in future modules. So I have this line here, so you can update this path to some other location. So if you want to save it to the local directory, you can just remove all the stuff before the slash and save to this particular file. And this says for each tweet in our list of textually relevant tweets, then we'll go ahead and write out the JSON version of that tweet. Now, before you do this, it will be useful for you to go through and look at these users, look at these hashtags, and look at these tokens, and see if there's any information that you should use or any information you should include in your original list of keywords. So for instance, for us, we used Brussels, bomb, Belgium, and explosion. And looking at this content, perhaps we should include Zaventem, some alternate spellings for Brussels, spellings for Malbeek, to increase the number of relevant tweets that we found. All right, and now you'll have a list of relevant tweets that we can use for analysis later on throughout the course. So for homework 5, recall that all I want you to do is go through this notebook, update your crisis info dictionary here with information relevant to your particular event, and then run this analysis using the information that you've put together along with the content that I've provided you for your particular timeline. All right, if you have any questions, as always, post on Slack, and good luck.